Hi, sixth grade. Today we are going to continue our prime factorization. So this time we're going to find the greatest common factor of two numbers using factor trees. And all of these skills are going to help us as we continue learning about fractions. So we have two main goals. Number one, we're going to use factor trees to find the prime factorization of a number. And this is exactly what we did yesterday. And goal number two, we're going to use a pair of factor trees to find the greatest common factor of two numbers. So each problem is going to have two factor trees instead of one. So just this one sentence of notes today, and then we'll get to the examples. So the greatest common factor of two numbers is the largest number that can go into each number evenly. So remember that factors are numbers that go into a number evenly. So the greatest common factor will be the biggest factor that both numbers have. So greatest common factor. And what we'll learn tomorrow is if we have a fraction, such as 30 over 72, if we divide 30 over 72 by the greatest common factor, that will get us to our most simplified fraction. So for those of you who were dividing by 2, and then dividing by 2, and then dividing by 3, you can save a lot of time by finding the greatest common factor. Some of you are already very good at looking at two numbers and knowing the greatest common factor. Those are just math facts. But for those of you who are not, these factor trees should help. So, for example, on some of your problems, you are going to get two numbers, and you're going to want to find the greatest common factor. So what we're going to do is we are going to split this into two factor trees, and I'm going to use different colors. So for 30, we can break that apart into a few different ways. I'm going to do 3 and 10. Circle my 3 because it's prime. Split my 10 into 2 and 5. And that leaves me with 2 times 3 times 5. And for my other factor tree, I have 72. Let's split that into 8 and 9. The 9s will split into 3s. The 8 will split into 2 times 4. And the 4 will split into 2 times 2. So my blue will be 2 times 2 times 2 times 3 times 3. So I have two factor trees. So I found the prime factorization of two different numbers. Here is the new part. What you are going to do is you are going to identify pairs of numbers. So you're going to look for numbers that are found in both factor trees, and each number can only be used once. For example, there is a 2 here, and we're going to pair that with this 2 here. And we're going to write that here in the middle. There is a 3 here, and there is a 3 here. So we're going to write that number in the middle. And as you can see, there are no more pairs because this 5 doesn't have a pair. These 2's, they don't have a green pair because this one has already been used. And this 3 does not have a pair because this 3 has already been used. So we're left with 2 times 3, which equals 6. And that makes 6 the greatest number that can fit into 30 and 72 equally. So all that we did was we found the prime factorization of each number, and we identified the pairs. After we found the pairs, we multiplied them together and found our greatest common factor. We're going to do a few more just so you can see. All right, so if we have the numbers 24 and 84, let's start with my factor tree here. I have 3 times 8. And remember, you can multiply like 6 times 4 or 12 times 2, and you're still going to end up with the same prime factorization. The 8 is going to split into 2 times 4, and the 4 splits into 2 times 2. So I have 2 times 2 times 2 times 3. The main reason I like to practice writing the numbers from least to greatest is just so I can stay organized. All right, 84. Let's start with 2 times 42. Then I can say, let's do 6 times 7 and 2 times 3. If you're good at your math facts, these factor trees can go pretty quickly. So we have 2 times 2 times 3 times 7. So we have 2 sets of prime factorization, and now we're going to look for pairs. This 2 can be paired with this 2. Put that there. I'll even change colors. This 2 can be paired with this 2. So it's perfectly fine to have more than one pair of each number, but both of these sets, 24 and 84, have multiple 2's. And our last pair is going to be these 3's. Say times 3. And this 2 and this 7 don't have a pair, so we have 2 times 2 times 3, which equals 12. So the greatest common factor of 24 and 84 is 12. So 12 can go in evenly to both of these numbers. Okay, 45 and 63. Let's go 3 times 15 and 3 times 5. So that leaves us 3 times 3 times 5. Over here we have 3 times 21 and 3 times 7. So that is 3 times 3 times 7. So I have a pair of 3's here. Better box that one. And another pair of 3's here. And that leaves us with 3 times 3 in the middle, which equals 9. So just a quick recap. We do the prime factorization, and then we identify the pairs. So we have 1 or 2 more. 15, that just splits into 3 times 5. Those are both prime numbers. And 42, let's do 2 times 21 and 3 times 7. So that is 2 times 3 times 7. We have a pair of 3's. And that is it. That is our only pair. So that means our greatest common factor is 3. All right, 20 and 57. We want to find the greatest common factor. Let's do 2 times 10 and 2 times 5. And that leaves us with 2 times 2 times 5. Over here, this one is actually 3 times 19. And those are both prime numbers. 3 times 19. And the main idea of this problem is to show that sometimes there are no pairs at all. There are 2 2's here and 1 5, and there aren't any 2's or 5's over here. So when this happens, that means that there are not any factors greater than 1. So our answer is just 1, because any number has 1 as a factor. So on your assignment today, you're given a pair of numbers. Draw out your 2 factor trees and find the greatest common factor. I understand that a lot of you are able to find these in your head, but I would still like you to draw the factor trees. Thanks.